we're going to turn from page 3 to page 4 in our circle book, and we're going to look at a circumscribed quadrilateral. C-I-R-C-U-M-S-C-R-I-B-E-D, quadrilateral. Okay? C-I-R means circle, so that means like around. Okay? So a quadrilateral where all four sides are tangent to the circle. A quadrilateral where all four sides are tangent to a circle. Okay? So if we've got a circle, and we are to have tangents that are connected to it, we've got like A, B, C, D. We know these are equal. We know these are equal. We know 1, 2, 3 and 1, 2, 3 are equal. D to C is equal. No, these are all 2, 3, 4, 2, 3, 4 are all equal to each other. Well, in this sense, we understand that AB plus DC equals AD plus BC. So these sides over here and these sides equal these sides and these sides. And that'll become more obvious as we show some examples. So it's just stating that the sum of the lengths of the opposite sides are the same. Of the opposite sides are the same. Okay, now we're going to talk about common internal tangents. Common internal tangents. Okay. Common internal tangents, if we've got a circle here and another circle here, and they have a tangent line that touches on both of them, and it's in between the two lines, that is called a common internal tangent. Now we know again that they've both got a radii, and they meet at 90 degrees. Okay? So if they meet that tangent at 90 degrees right there, and we want to know, we've got the distance between the two radii, is this line right here. If we want to find the lengths of that common tangent, we can kind of build up here, and we can make this radii and this radii the same, and we can kind of build a right triangle there, so that these, not right triangle, a rectangle, so that these two sides are the same. So remember, this is the first radii, radii 1. This over here, that's radii 2. But then we can make this a whole right triangle right here. I'm going to kind of outline this in purple. This ends up being a right triangle right here, where these two match. So this right here is a leg. That's the distance between the two centers of circles. That's the hypotenuse or the tangent. And this right here is radii 1 plus radii 2. Okay, now we're going to talk about common external tangents. And I know that didn't make the best sense, but we'll do some examples when we do this second page of your tangent packet, and it'll make a lot more sense. This is common external. So external means on the outside. So if we've got two circles our external tangent is right there on the outside. And again, we've got a radius for 1, and we've got a radius for 2, and we've got right here, that's the distance between the two radii. And we can kind of right here be like, all right, we need to figure out what that is. So we can move this parallel down here. So we've got a right angle. And know that these two, the common external tangent and this line here where we built this, I'll use a different color, we built this rectangle on the top of it. Those two sides are going to be the same. But then you see that we have this right triangle right here. Well, this is the distance between the two circles, centers of the circles. And I'll just write that all out. Distance between centers of circles. And if this whole thing is R2 and this is R1, well, this is R1 and this is R1, so we could just go R2 minus R1 is this side. And then that's the hypotenuse. And do you see how we kind of have a Pythagorean theorem we can do there with this red one? We don't know what this is. We know the hypotenuse is the distance between the two circles, and we know this little leg right over here is R2 minus R1. Again, we're going to do some examples so then it will make even more sense. Okay, let's try some.